In this video, I'll show you how to delete a node on a binary tree using a program in Python. The problem is that you have to delete a node on a binary tree without violating the binary tree property, which is that each node has two children, a left children and a right a max two children. So the input is a tree and value v. For example, the v is 11 in the output would replace v's value, which is 11, with the rightmost node value, which is 8. So now v's value, which would be v value, is 8. And which would be the rightmost node value has been deleted because you delete it, so it moves the rightmost node, so now it's deleted. It creates a class and then it makes its right and left to be none. It makes its value to be your input. Node 10 is root. Node 11 is its left to root, and node 7 is its left. It's second left. After going left once, you go left again, and you'll find 7, and so on until you're done loading the tree. The function deletion replaces and deletes the values rightmost node and the rightmost node and the input, and it takes the input of the key, which is 11, and the tree. It calls the function find rightmost node to find the rightmost node. And it calls the function find node to see if it's in the tree or not. If it's not in the tree, then it will then find node will return none. So it checks to see if it returns none. If it doesn't, then it will replace your input value with the rightmost node value, and then delete the rightmost node value. The code to find the rightmost node it uses BFS and then returns the number it last ends on. BFS is done using Q. For example, to use a Q for BFS, push the start node, which for this tree is 0, and then into Q. Then you pop out the friend, which is 0, and add the neighbors 1 and 2 to Q. So now Q is 1 and 2. And you pop 1 out, because that's the friend of Q, and since 1 has no left child, it only pushes 3 to Q. So Q is now 2 and 3. Then you pop out 2, because that's the friend, and since 2 has no neighbors, you push nothing to Q. So it has 3 left. And it pops out 3, and since Q is now empty after popping out 3, you visit all the nodes in the tree. The last node is the rightmost node, and because 2 is not the rightmost node, because 3 is because it has to be on the last level rightmost node, so 3 is the rightmost node in this case. So it creates Q to be empty, and you append its starting node of the tree to it, root. You have while loop, and then you pop out the front and append its left and right until it's empty. And it will return the rightmost node, 8. The code to see if 11 or your input is in the tree also uses BFS. It makes Q empty and appends to it again, and then has a while loop and pops out the friend. And then checks to see if the friend value is equal to key, because if it is, then you need to return it. And if it's not, it appends the left and right until it will walk until it follows out the while loop when Q is empty. If it still hasn't found the node that has the same value as key, then it will return none. And this function in order prints each node on the tree recursively, printing its left, and then itself, and then its right. After deleting node 11, the in order print of the tree will be 7, 8, 12, 10, 9. The end. In summary, we show you how to write a program to delete a node on the tree without violating the binary tree property, which is each node has to have max 2 children.